So this is where we were in our last session, right? We had just created an S3 bucket. We had created a DynamoDB table, and we also had a random string which helped in the S3 bucket creation, since bucket names need to be unique. Now, one thing that you will very clearly notice is that we have a lot of hard-coded values, right? For example, we have specifically said, okay, 16. Include special is false, uppers are false. Now, as programmers, as engineers, we know that hard coding values is a big no, right? I mean, I don't want to make a change in the code if I have to, say, for example, change the length of the random string. Okay, so how about this? How I run you through the individual resources one by one. It's small, so it shouldn't take any more than 5 minutes, right? So the first thing that we do for any Terraform block or Terraform resource is that we specify a provider, right? Now, provider essentially dictates Terraform where it will target its resources. Now, since we are focusing on AWS, we specify that, okay, our provider is going to be AWS. We specify a region of where our resources will mostly be deployed by default. And we have a profile as well. Now, this profile is essentially the same profile as you have in your local AWS CLI configuration, right? Whenever you install AWS CLI, you need to configure a profile for that. So this essentially is just the name for that. The next thing that we do is we create a random string resource, right? Now, this is this is sort of like a helper resource for us. This isn't exactly creating a resource on AWS, but it's more on the Terraform side where it creates a random 16 letters long string, right? If you see on line 13, we use it as the name of our S3 bucket. We need that because S3 buckets need to be globally unique. So yeah, since S3 buckets need to be globally unique, we append this. Now, this obviously does not guarantee that our bucket name will be unique, but it gives us a good enough chance to play around with, right?
So this is a kind of a local function.
The random string?
Yeah.
Yes, essentially, yes. In fact, we'll also come into what functions are, hopefully in one of the sessions in the future. Terraform does give us some fancy functions like toList or toString, etc. They do exactly what you think them to do. It converts to list or it converts to a string. Then we specify a few parameters to the S3 bucket and to Terraform as well. For example, if you see the lifecycle block, this is an instruction to Terraform and not to AWS or to S3 to basically prevent accidental destruction of the resource. The objective is that this bucket will be used as our state bucket. I'll come to what states are in this lecture, in this session, and I'll define why we need it, right? So since it is a central part of Terraform, we do not want accidental deletion of such a sensitive bucket, right? That is why we specify this. Then we enable versioning and we enable some server-side encryption, right? So this basically wraps up our S3 bucket. The next thing that we need to maintain and manage states are DynamoDB Table. This is a requirement from Terraform. And again, I'll be coming to what state files are and what all is required in this specific session. We define a very simple DynamoDB table with paper requests as a billing mode so that we don't end up getting charged. Even though all of this is in free tier, we do not want to consume our free tier resources just out of need, right? We specify lock ID and we also specify the type of, what the type of that lock ID is, right? So this is again a requirement from Terraform to have an attribute called lock ID, which is what Terraform uses to lock our state files, right? If you are familiar with the concept of semaphores and mutexes, DynamoDB table essentially acts like that, right? Terraform uses the DynamoDB table to lock the state file so that others cannot make changes to it. I'll be explaining more on it on this specific session. We'll come to that, right? So that is basically what all we discussed in our previous session. In this one, we'll be focusing on variables and we'll be focusing on data sources and state files, right? I will not be going into extreme depths of state file because that's a huge topic in itself. I'll be at least ensuring that we all are familiar with what a state file is, what it looks like, and what are the mechanics around state file and its communication with Terraform, right? So to that end, I think the first problem that we find in this specific file is that a lot of the variable values are hard-coded. right? We have, for example, UC true, the encryption algorithm, the billing mode, the hash key, all of this is hard-coded as a part of the code. Now, we all know that as developers, as engineers, as programmers, this is not exactly something that we should be doing. Variables should be, they should be exactly that. They should be variable. They should be defined when you want them to. They should be able to change their values, right? So to that end, let's fix that. So if you recall, we had created 4 files: main.tf, out.tf, vars.tf, and terraform.tf vars. So what the convention that we'll be following is that all our variables, input variables, will be defined on the vars.tf file. All our output variables will be defined on the out.tf file. And the value of the variables, right? If you want to override any value, we'll define that in the terraform.tf vars. Now, this is just a convention that we follow. Terraform internally essentially merges all the .tf files together to create one huge file and then deploys the resources as required. This is just so that we can understand it better. So let's start with that. Let's first create the variables for the first set of resource, right? Which is that random resource. Now you see there are 3 specific variables that we can pass, right? So we do that. Now the syntax for that is very simple. We start with what type of resource that you want to create. In this case, it's a variable, so we define that it's a variable. We give it a variable name, right? We give it a small description, a type, and a default. So it's a lot like if you consider a programming language, it's like the type is our data type, int, boolean, string, whatever. This is the name of the variable, right? We'll use this specific string, this specific random string length to refer it in other places. We give it a default value. Now this is optional, obviously, but it's just we want to give it sensible defaults so that if nothing is specified on terraform.tf vars or on the CLI, it'll fall back to the default value. Description is just to help us. Terraform doesn't care what you write in the description. It can be anything. It can be any arbitrary string. It's just for other developers, other ops engineers, other Terraform developers will be working on this. Similarly, I added 2 more variables for include special and include upper. Now, since these will be Boolean values, I specify that the type is Boolean, right? Similarly, now once this is done, we need to use it in our resource as well, right? To that, it's rather straightforward. You just write var dot name of the variable that you want to refer. So if you notice that here, I replaced the hard-coded values with a variable. Now, instead of the value being fed directly as a part of the code, it is now being fed via the variables. Any questions till now about this? Perfect. That deafening silence is a no for me. I'll move on to the next one. So just like we did for random string, we'll create variables for our S3 bucket and our DynamoDB table as well. And just like if you notice that we have a prevent destroy, we have versioning, and we have an encryption algorithm. We want to transfer these to our variables, right? Now, I have intentionally put prevent destroy as a variable here. We'll eventually find out that it's actually going to cause an error, right? Similarly, just like how we did in random string, we use it here in the same way that we did previously. We var dot whatever the variable name is. Lastly, we do the same for our DynamoDB table, DynamoDB variables, and we use it here, right? Now, if I go ahead and try to apply this, I am expecting that I'll get an error here, right? Now, there are some parts of Terraform where it does not accept variables, right? Now, if prevent, destroy, or a lifecycle block should not be accepting variables. We don't want that to change as it goes ahead, right? That should not be a variable. That should be a constant. So that is a restriction that Terraform has imposed on us, and thus we cannot be doing something like this. Let's get started with that, right? So I move on to my folder. I have the 4 files as we had initially seen. I initialize Terraform. So if you recall, yeah, perfect. So if you recall, for applying any resources, we need to do 3 things. We need to first initialize Terraform. plan it, and then apply it, right? The Terraform init step essentially downloads all my provider plugins, all the binaries that it needs. It initializes the modules of Terraform. It initializes any templates that we have and stores it in a local cache, right? Once that is done, we plan. Plan is where Terraform actually looks at what is deployed and what my code says, compares it, and generates essentially a change log of what it's going to do. And apply is when it finally actually deploys those resources onto the cloud provider. Now, as expected, as I was saying, that prevent destroy cannot have a variable, right? So that is exactly what it's saying here. We'll eventually fix it as well. Moving on to the next one, if you notice that here there are some variables in the vas.tf file where we do not have a value defined, right? We have some default values here, obviously. But I think default is only there for 3 or 4 resources. Again, default is supposed to be a fallback value and not generally the exact value that you want to have for the specific resource. To specify the value, we ensure that we have a terraform.tf vax. Now, this is a default file that if Terraform sees, it uses as the values file. If you do not have a terraform.tf vax, but have some other tf file, you need to explicitly instruct that to Terraform. Now, in terraform.tf vax file, all we do is we specify the variable name and what value we want it to have. This takes precedence over our default values. So whatever values are specified here will be what actually gets deployed to a resource. For example, I have intentionally put random string length as 15, whereas the default is 16, right? So you'll notice that when we do deploy a resource, our random string length will be 15 and not 16. So this is just something that you've got to remember when you're building out the Terraform resource of what variable values takes preference. Just to fix what we initially had, right? You remember Terraform did not allow us to have a prevent destroy as a variable. So I removed that. Now, once that is done, we can successfully run Terraform init. This will, as I mentioned, this will download all my providers. Now, since I have AWS and random as my providers, as my resource types, it will download all of that. It will generate a terraform.log file, which essentially contains the hashes of the downloaded binary, right? If you notice, there's a terraform.tf log file here. If I cat that, you'll see that all it contains are just hashes of the two resources that we have of random and AWS, right? Now, once that Terraform is initialized, I can go ahead, I can apply this, I can plan this out. Now, since I am using my local AWS profile, I know that nothing is deployed there. There is no S3 bucket, there is no DynamoDB table. So I'm expecting that once I run Terraform plan, it will be creating all these resources. So I should be able to see that X number of resources are created, no changes, no deletions, right? Let's confirm that. I'm expecting 3 resources to add. Perfect. As I just mentioned, it will create 3 resources. Now, as Prathamesh was initially mentioning that this random string is like a local function. Yes, it is. It is not creating any resource on the AWS side. All it is doing is creating a resource on our state file. Once I apply this, we'll also have a terraform.tf state file in our local file system. I'll be showing you what the contents of it are, how they look like. So let's go ahead and apply this. Right. It's generally advised that you review what the changes are. Now, what all Terraform is going to create and what exactly it's going to be like, right? So I've done that. Believe me, I've done that. So straight up go ahead and say yes. Once this will take some time. It is now actually creating the S3 bucket and the DynamoDB table. I'll run an AWS S3 LS to show you what the S3 bucket name is. I'm expecting it to be appended with this ID. Perfect. Right, as we can see, the ID is appended here as is. right? So we have an S3 bucket. We have DynamoDB table created as well. Let's move on to the next one, right? This is where we actually create something where we'll see the use of state files, where we'll also use this use of other types of variables. But before that, I'd like to show one more thing, which is called a local variable, right? So Terraform has mainly 3 types of variables: input variables, which you can see in your vas.tf file. You have output variables and you have local variables, right? So generally, again, just as convention, we specify all our output variables inside the out.tf file. If you notice, we created 4 output variables. It just prints out the name, the bucket ARN, DynamoDB table name, and the DynamoDB ARN, right? You can have a lot of other output variables as well. You'll have to refer to the documentation of the specific resource. For example, if it's AWS DynamoDB table, you'll have to refer to the documentation, find out what the attributes it has. And only those can be used as output variables. Or you can even build your output variables. You can have an output variable which just prints hello. It's up to you if you want to do that. The other thing I mentioned was local resources, right? So local variable, sorry. So a local variable is generally defined under the locals block. We give it a name and we build out whatever value we want to specify to it, right? Now, if you're familiar with local variables in programming, this is essentially the same. This bucket name local variable is limited to the scope of these resources only. I cannot be extracting this out to some other resource which is not in here, right? Or even I can't even pass it as a CLI parameter or via Terraform.tf. It is just limited to the scope of this file. Now, this was just for demo purposes. I understand that this does not exactly serve any value here. Instead of building out the bucket name here, we mentioned it as a local variable. The objective was to show what a local variable is and not exactly to have extra features, extra fancy things. We can go ahead and apply this as well. Now, since we did not exactly make any changes to the infrastructure, we just modified it a bit from aesthetics perspective. We gave it an output value. We gave it a local variable. We don't expect any new resources to be added, right? We just expect new outputs. So let's go ahead and apply that. Once this is done, I'll be showing you what the Terraform.tf state file looks like. We'll be diving into some depth into it, but not into a lot. It's an extremely vast topic in itself. I feel like the state file deserves probably 2 sessions on itself. Right, so as we expected, nothing to add, nothing to change, nothing to destroy, just the changes to outputs, right? So it'll add a few outputs to my state file. So I'll go ahead and I'll say, okay, cool, let's get that done. Once that is done, so this is a change that you might notice between our previous apply step and this one. Here we get an outputs section, right, where we get the name of the bucket, the DynamoDB ARL, the whatever we specified in the outputs file. Just to prove that this is something new here and not in the previous one, I'll go ahead and I'll show you what our previous output was. Yeah. So once we ensure that we've written yes, it just says apply complete and that's it. No output here. But here, in our case, we can see that there is an apply complete and then we have outputs. Cool. With that, I think we have covered at least the state bucket creation side. Let's move on to something different. Where we'll be creating a user, right? Now, in AWS, I think users, roles, and policies play a central role. So we are diving into AWS specific side of things a bit, but obviously this can be translated into other resources as well. One of the conventions that at least I follow, and I've seen a lot of other developers follow as well, is that whenever we create a new folder for Terraform, we touch these 4 files, right? We create empty files for the 4 things. Even if the end result is that the out.tf file is empty, Cool, nothing to worry, it's just another file on Git, right? It's not adding to our binary size or anything. It's not adding any load for that. Let's start, right? So the first thing that you notice is providers. This is something common. This is something that we've seen in the S3 bucket as well. The new thing here is the Terraform block. Now, the Terraform block is where we define instructions to Terraform, right? We specified a backend here. Now, backend, this is where our S3 bucket from the previous step ties in, right? We specify a Terraform backend. And now what will happen is any state file locking will be configured via this backend. Once we initialize, we provide it, it'll then create the S3 file. I mean, not create, but it'll see if it exists. It'll ensure that I'm able to successfully lock onto that file and get it done. Just to prove that, okay, I'm not lying, I'll show you the Terraform state here. Right? It's a huge JSON file. And since it's JSON, it's human readable as well. We can easily go through it. We can see what all it does. It has specific sections for resources, for outputs, and then eventually we have for data sources as well when we come to that. So this was for the DynamoDB table, the S3 bucket, and the random string. So you can see that we'll have 3 resources as mentioned by Terraform. One, AWS DynamoDB table, has a lot of attributes around it. We'll have one for S3 bucket, which is here. And then lastly, we'll have one for the random string. The 3 resources are created here. The Terraform.tf state file for the case of S3 buckets was on my local file system, right? That is because I did not specify a Terraform backend. Now, if we go to the users directory, right, I'll run a Terraform init and I'll specify a backend config. It'll throw me an error, hopefully. Yeah, perfect. That is because my backend.config file has incorrect bucket. Right, the bucket name was different. It wasn't this. This is one of my previous sessions. Now, I do not want to be changing the bucket name every time, but since I delete all the resources after each and every session, the random string tends to change, right? Let's fix that, right? I'll change the bucket config to this, right? So this is what my buckets, my S3 bucket is like. Now, when I run Terraform init with the backend config again, it will find out that, okay, this bucket actually, did I do something wrong? Give me a second. Okay. Yeah, so I think that was because I had initialized the Terraform before, I mean, with the incorrect file, right? So Terraform was trying to migrate my state file from the previous bucket, which was an incorrectly named bucket, to this new one that I'd specified. So Terraform is also smart that way. I think this is, again, something we'll be seeing in the future sessions, where if you change the bucket name or the key in the bucket, essentially the path of the bucket, Terraform will automatically prompt you to migrate your state file from the previously configured backend to the new one, right? So that is what Terraform was trying to do here as well. But since my old bucket did not exist, it was throwing a S3 bucket does not exist error. Cool. Now, once that is done, so this was just the initialization bit, right? I'll move on to the next one. We want to create an AWS IAM user, an access key, some policy around it, and we'll attach that policy to our user as well. Now, just to show you that I don't have any existing users, I'll have just one. It'll take me probably 15 minutes just to log in. I mean, AWS is really secure about this, so they'll prompt me for a CAPTCHA, prompt me from MFA, but all in good faith, right? Okay, so on users, I just have one user for serverless, which I've not used in ages. Actually, I've used, but I should be rotating the keys for that. Once we're done with applying all these resources, you will see that there's another dummy user created here. So let's get started with that, right? So just placeholder values here, dummy user, dummy profile as well, since we'll be deleting all of this eventually. As I mentioned, we need user, access key, and policies, right? This is rather simple. I think you can read the documentation to understand what are the parameters here individually. We are inching closer towards AWS territory. That is not the scope of these Yoda sessions. This is specifically for Terraform. So I'll be skimming over them, right? This is something new that we've seen, right? The data block. Till now, you've seen resource blocks. You've seen local, you've seen types of variables. This data block is something new to us. Now, data block in Terraform is nothing but it's just a way of computing, right? This data block, whatever you see between line 10 to 21, we are not creating any new resources here. We are just instructing Terraform to build out sort of like a JSON for me, right? Which is instructed by our AWS IAM policy document. The types of data resources that we have and the types of resources that we have are limited, are defined by the provider, right? So for example, if my provider was GCP, I can't be using this. This is very specific to AWS, right? We can use this for creation of IAM policies. We can use this to fetch remote states. You can have plethora of data sources. Obviously, I urge you to go out, check out the documentation to see what all data sources we have, and you will see just the bizarreness of options that you have, right? So we give it a small policy here, right? And any AWS policy needs to have an SID, some action, the resources it is allowed on, and what effect does it have, right? So we give it access to just S3. You can do whatever you want on S3 on all the S3 buckets, and we allow it, right? You can have either allow or deny here. Again, I'm skimming through these because this is AWS specific. That is not the scope of this session. We want to focus on Terraform and not in AWS, right? Now, once this is done, once we've built out the AWS IAM policy, we need to attach it to our user as well. Because if you see right now, this policy and this user is independent of each other, right? Let's fix that, right? So we create an IAM user policy. We specify the name of the policy. We specify what user we want it to. Now, if you see, we've referred the AWS IAM user. We've specified the resource name that we have given. And since every resource has its attributes as well, we know that the name attribute will give me the name of that AWS user. Similarly, we do it for policy as well. We use the data source. So data.aws IAM policy.dummy policy.json. Now, again, this JSON is something that AWS IAM policy has as an attribute. We can leverage that because policy accepts only JSONs, right? Imagine this thing to be like a class, if I'm to create that analogy. There might be some discrepancies here and there, but hear me out. This class has 20 attributes, right? Which you can refer to by the getter setter methods. So when I do .json, that essentially invokes the getter method and returns the JSON for this object. Sorry about that, it was my lunch. Right, so we essentially, the JSON is one of the attributes of this specific class, right? And that is how we refer it. Simple documentation, how we do it in other languages as well. Okay, now once that is done, I think we can safely go ahead and apply this. But one thing that you'll notice is that still a lot of things are hard-coded, right? Another problem that we'll face is that this access key is, we do not have the secret key at the moment. We need to specify a PGP key so that Terraform can encrypt that and use keybase to encrypt and give me a secret key. Since we want to access this specific user via the AWS CLI, we should be able to generate the output as well. So I define a variable called PGP key, which we'll give no default value to it. We'll not even specify it by Terraform VAS because it's a bit sensitive, because I'll be essentially specifying my keybase ID. You can either specify a keybase ID or a base64 encoded PGP key, whatever you're more comfortable with, right? So, and I ensure that we have that written in the description so that other developers can easily access that. Once that is done, so I specify the PGP key here as well, right? So that, I think this is yeah, I specify the PGP key here, so that access key this resource can use that PGP key and create my encrypted secret. And I output it out on my out.tf file, right? So as I mentioned that if those are classes, we have individual attributes where we can get the values from. This is just another way of getting the value, right? Moving on to the terminal, we are ready to finally apply this, right? So we have already initialized it, right? So we don't need to do that again. We can run a Terraform plan. We'll see the change log now. Since nothing about this code has been on AWS, my Terraform will output that, okay, it wants to create 3 resources, right? The user, the access key, and the policy attachment. For the purpose of security, I will not be showing the final decrypted key, but I'll show you that the AWS user is actually created on my AWS account, right? I'll go to the console and show that to you. So as expected, it wants to create 3 resources. Let's get that done quickly. While this is creating, I'd like to point your attention to one fancy thing that we saw at the beginning, right? It says acquiring state lock. It says acquiring state lock, right? This isn't something that we had seen in the state S3 bucket creation, right? Because we did not specify a locking mechanism. Since we have specified a locking mechanism here with the help of DynamoDB Table and the encryption equal to true parameters on the Terraform backend block, Terraform now acquires a state lock. While it has the lock, no other Terraform developer can apply any changes to these resources, or at least to the resources that are managed by this state file, right? So this allows multiple developers to be working simultaneously without overlapping on each other, without stepping on each other. Okay, perfect. Now that is created, as expected, I get an output with my encrypted secret. I can decode this using keybase, and it will give me my secret access key. This is my access key, right? Now, to show you that this has actually happened, right? Perfect. As you can see, we have a dummy user here. It has some policies, as we had mentioned here, dummy policy, and the policy summary is as such, which is exactly what we had specified on Terraform as well. So that essentially wraps up the user creation, the variables, the data sources, all of it. I'll finally bring your notice to the state file side of things, right? Now, if you remember, we had an S3 bucket, right? And that S3 bucket was empty. While debugging, we saw that it was an empty file, right? Now, if we go to this one, we have a users folder, and we'll have a terraform.tf state file here. This path is dictated by our backend config, right, which we have here. We had specified the key to be users/terraform.tf state. So for Terraform, my backend essentially becomes my bucket name / my key, right? And you can see that is exactly what is happening here as well. We can also see the content of this this file. Let's go ahead on S3 and download that. Any questions, any doubts that you guys have in the meantime that I download this one? Anything you feel like should be explained in a bit more depth?
Okay. I think it's fairly reasonable.
Okay, cool. So this is now, if you recall, while we were building the S3 bucket, our state file was local. What that does is, if somebody else wants to make any changes to that S3 bucket, they'll need that state file, because that state file is my source of truth. That state file is what Terraform uses to understand if such a resource has been created or not, right? That state file enables synchronization between two remote developers or two remote users about our AWS, about our cloud infrastructure, right? And the moment we push it to S3, that becomes accessible to everybody who is using that cloud provider, right? If you have access to this AWS account, you have access, and we give you access to this S3 bucket and the state file, you can easily communicate with it. You can see what is deployed. Terraform can see what is deployed, what isn't. And it can compare and contrast what needs to be done. So the state file structure looks essentially the same, right? I mean, that won't change, but the contents of it will change. As you can see, we have an output section here. We have a resources section, and we also have a data section here, right? A type of resource called data, right? Which just contains my JSON. Now, this state file also gives you an idea about what attributes an individual resource or an individual data block has. We use the JSON attribute, but it has ID, it has other attributes which we can eventually use, right? Similarly, we have for resources as well, right? Every resource will have some attributes, some things that you can later on use, like we have in our code. So whenever I make any change, for example, I'll go ahead and I'll make a change to my to the policy, right? Along with S3, I'll give it permissions for EC2 as well, right? Now, when I do Terraform plan, it will compare. Terraform will compare my code. It will generate a temporary state file as such, and it will compare with what is actually deployed, what is on cloud, right, on the S3 bucket. It will see what the difference is, and then determine what all new resources to create, what all to change, what to modify. Since we've made a change, we have not added anything. All that will happen is the policy will change, right? We can go ahead and apply this as well, and I'll show you how the policy changes on AWS. So all we did was we just modified it of giving it permissions on S3 to EC2 as well. Once we move to our IAM users console on AWS, we can see that the permissions have changed. Voila. So I think that wraps up at least the code and the description side of things. If you have any questions about it, I mean, essentially the last couple of minutes are for Q&A and for feedback as well. If you feel like maybe I rushed through something or did not, needs more attention to, do let me know. It will help me improve my next sessions. If you have any questions, now is the time. I'm obviously available later on Slack as well. I'll be happy to pair with you to build out exciting cloud infrastructure.